Welcome to Art 101, Introduction to the Visual Arts. My name is Carl Jennings and I will be your professor for this course. With these first couple of slideshows, I want to touch on some of the basics for the course, a lot of the stuff that we're going to be returning to in many forms. This first slideshow is called Visual Perception, and we're looking at the nature of visual perception and some of the misunderstandings related to it. There are two aspects to how we physically and conceptually see the world, and they are the physical apparatus that we possess, our eyeballs and the structure of the eye and our brains. But how we see things and how we perceive the world is also greatly influenced by less tangible things such as cultural, social, and conceptual models and ideas that we grow up with, we inherit, or we assume at some point in our life. And both of these things influence how we actually do, in fact, perceive the world. If we were to look at a traditional model of how we see the world, or what I call the common sense view, it would look something like this: that you wake up in the morning, you open your eyes, and the world jumps in. In this way, you are merely a passive recipient, and you assume that what you see is what's actually there because it's entering your eye. This tends to consider the whole visual system as being very much like a camera. However, it is really just the eye that is like a camera, and here is a diagram of the lens and the image of the number 5 passing into the camera, and we see how it gets flipped upside down at the back of the camera where the film is. Similar to the eye, it does also flip upside down and hits part of the eye called the retina, which is where we have the various photoreceptors which pick up the information. So this part of this half of the system is passive. The images are entering physically the aperture of the eye, much like a camera. However, there is another element to it, and that's the brain. And what the brain does is it turns this whole system around. And so a much more contemporary model of how we actually see the world would look like this. It makes the direction of perception an active one on the viewer's part, so that what we do is not a passive reception of information, colors, shapes, people, events, but rather our looking and our viewing is an active act of going out there into the world and choosing and selecting and working with the information that's there. And so another way of thinking about this is you have something between you and the world, and I apologize for the slides a little messed up, but between you and the world is something called the imagination. What the imagination is something that's often confused by people. It's not the ability to just make up fanciful images or dream-like things. The imagination is actually much broader than that, and lots of philosophers and neuroscientists and researchers in this field are beginning to see that the imagination actually underpins many of our cognitive faculties. What the imagination does is it provides a way of imagining what we think, what we see, what we believe, and this whole act is what intercedes between us and the world. So our imagination, the way we imagine the world to be, the way we imagine ourselves to be, and the way we imagine situations to be as they arise, is an active process of selecting, editing, interpreting, and projecting ideas out onto the world. This is a very important thing to understand, one that we'll be coming back to repeatedly in the course, is that we go into the world with our perception and we see things basically that we want to see, or we see things, we connect them to things we're already familiar with. And so within a fraction of a second of seeing somebody for the first time, for example, we will sort of decode very quickly in our mind what we think of that person in terms of what we think they're like, where they're maybe where they're from, and maybe the personality traits and things like that. And so this active role of selecting things to look at, of editing what it is we do look at, of interpreting it, projecting it, is an active role, and the phrase judging a book by its cover pertains here. But the other side of that phrase, judging a book by its cover, what you see at first sight, it can also be very dangerous. And so this active role is prone to distortion, that we can see things incorrectly in terms of how they actually are in themselves. And so, for example, one of the things we want to notice when we're looking at the visual system is that we can actually see things that are not there. We can make things up. This constructive role of the visual perception system can be demonstrated quite easily through optical illusions. We look at this image, for example. Many of you should be able to see a white inverted triangle in the middle of this image, when in fact you know that there is no white triangle there. You just have these three little Pac-Man figures and three V shapes all arranged in such a way that our eye creates the impression of a line going from one corner to another corner to another corner and outlining a triangle. And for some, the triangle is actually seen as lighter than the white behind it, and that it's somehow floating or superimposed. And so we're seeing something that doesn't exist. There's no triangle there, but our brains will construct a triangle. Another example, if we look at these two images, the one on the left, the one on the right, and we look at the central dots. They're exactly the same size. The circle in the left is no smaller than the circle on the right. However, the context, the environment, the surroundings influence how we see something. And so if it's surrounded by large things, it will look smaller, and conversely, if it's surrounded by small things, it will appear larger. So yet another case where things are one way, but we perceive them quite the other way. And here is an extreme example, and one that many of you might not believe, and so I encourage you to research it yourself. There's the name down there in the corner, Edward Adelson. You look him up online and you can check this out. In this image, the square A and the square B are actually the exact same gray. What I mean by that is, if we were to take a scientific instrument that measures light, and we were to shine it on A and shine it on B, the reading, the measurement, would be the same number, meaning that it's reflecting back the exact same amount of light, which means that they're basically the same gray. However, when we look at it, we see the A and we see the B as being two very different things. And so we're actually seeing a distinction that's not really there. Why is this happening? Two main reasons. One, it's that context again. You surround something by light colors like the A, it will appear darker. You surround something with dark colors like the B, it will appear lighter. And the other factor that's influencing the way we look is that we understand the black squares to be different than the white squares. And even though the white square B is in the shadow, which is how it's actually made darker, of the green cone, we ignore that shadow. We just tend to base our understanding of this on our understandings of checkerboards and how we've experienced them in our past. And so we know that even though B is in a shadow, it must be lighter than A, when in fact it's not the case. And here's an example of that broken down. You see the image on the right, the two gray stripes that pass through it. Notice when the gray stripe hits the square, the boundary disappears. That means that it's the exact same value, or what we call value is a term used in art to refer to darkness or lightness, often referred to as grays. And here's another example. The brown square in the middle of the top is the exact same color as the orange square in the shadow portion of the object on the left. On the right, you see those colors are all masked out around it, and we see that they're the exact same color. Again, very difficult to believe. The information is there, they're the same color, but our visual perceptual system will perceive them as different. So we, again, are seeing something that does not exist. How does this again happen? It happens also through experience. We understand that when something goes from being in the light to being in the shadow, it goes darker. And we see that happening to all the squares from the top as they go over to the dark side. However, if we make one of the squares stay the same and not go darker, then it appears to be lighter. The opposite of this is also true. We often don't see things that are actually there. For instance, the FedEx logo. Many of you are, I'm sure, are very familiar with it, and many of you might know the secret symbol that's hidden inside the FedEx logo. If you look closely at it for a little while, you pay attention to the letters, but also pay attention to the white spaces between, around, and inside the letters, something we call negative space in the art world. You will see a white arrow between the E and the X. And that arrow is put there by the designer to subliminally communicate to you that FedEx will move things from here to there. It will get the job done, it has direction, it has focus, and it has movement. Because we read from right to left, the arrow going in this direction is considered progressive. If the arrow is flipped the other way, then that would not be a very good message for FedEx to be communicating subliminally. It basically would mean that when you send your packages out, they probably will be returned and come back to you, and not something FedEx wants to do if they want your business. If we were to look at FedEx logos in other parts of the world, here's one. That's the Arabic FedEx. And because Arabic's written from right to left, you notice that the arrow goes in the opposite direction. Also, because we don't understand the letters, or most of us who don't understand or read Arabic don't understand the letters, we begin to see the symbols and the shapes a little more clearly because we're not reading the letters. We're actually beginning to look at it much more accurately in terms of what is actually there. And so here are a few more examples of designers using these tricks of negative space, the goodwill symbol. You look at the G, you see a smiley face. You look at Ed's Electric. He's got an electrical plug, which makes the E for his name. The black cat. You see the eyes of the cat are hidden in there. So this physical aspect of seeing things is, like I said earlier, it's twofold. There's the eye and there's the brain. The eye, depending on its physiology, will send different sorts of messages to the brain, and the brain, depending on its development, will interpret those messages in a certain way. But I just want to stay with the eye a little bit longer. Humans have in their eye 3 different types of cells called cones, and what they do is they are sensitive to color. And the types of cones determine what types of color you can see. So we have 3 of them, which means basically we have 3 colors that our eye uses to assemble all the colors of the world, like primary colors. If you're colorblind, it means you're missing one of them, so you only have 2 colors. And you can imagine if you only had 2 colors to play with, you would be able to produce a much smaller group of colors than somebody that has 3 different types of colors. So if we look at animals, we actually find that some animals have more than 3. They have 4, they have 5, and in the case of a particular type of shrimp, we have 11 different cones. So what this means is certain animals are allowed to see or able to see more than what we can. Here's an example. The top image would be what a human sees, and the bottom image is what a butterfly sees. Butterflies mostly have 5 different cones, which means they can see more information than we can. And so when they look at flowers, they will see markings, they will see patterns, they will see different sorts of stuff. So it really does depend when you ask the question, well, what's actually out there in the world, who's actually doing the looking and what kind of eyes they have and what kind of brains they have. But the conclusion to all of this is that our actual visual apparatus is quite limited. It's limited and it's partial. It sees things that are not there, it doesn't see things that are there. And it's not something that's terribly accurate and dependable in all cases.